When we talk about colonizing other planets, the first question that comes to mind is, why Mars? Out of all the planets and moons in our solar system, Mars stands out as the most promising candidate. It's often referred to as Earth's sister planet because it shares some key similarities. For example, a day on Mars, called a sol, is only slightly longer than a day on Earth, lasting 24 hours and 39 minutes. Mars also has seasons, polar ice caps, and evidence of water frozen beneath its surface. This makes it more Earth-like than any other planet we've discovered so far. But why not the Moon or other planets like Venus or Europa? While the Moon is much closer to Earth, its lack of atmosphere and extremely low gravity make it difficult to sustain long-term human life. Venus, on the other hand, has a toxic atmosphere and surface temperatures that could melt lead. Europa, one of Jupiter's moons, is fascinating because it may have an ocean beneath its icy surface, but it's much farther away and incredibly difficult to reach with current technology. Mars, in comparison, offers a more balanced challenge. Its gravity, though lower than Earth's, is enough to support human health long-term. And with advancements in technology, especially in building life support systems and creating habitats, scientists believe that living on Mars could become a reality within the next few decades, if not sooner. Beyond the practical reasons, Mars holds immense scientific and strategic value. It's the most likely planet where we might find signs of ancient life. Studying its geology and atmosphere could unlock clues about the early solar system and, potentially, the history of life itself. Additionally, colonizing Mars isn't just about settling on another planet. It's about preparing humanity for even deeper space exploration. Mars could become our gateway to exploring the rest of the solar system and beyond, making it the ultimate stepping stone to the stars. Mars offers hope, opportunity, and the potential for humanity to become a multi-planetary species. That's why Mars is at the top of the list for interplanetary colonization. Mars colonization is no longer just a distant dream. Multiple space agencies and private companies are actively working toward making it a reality, pushing the boundaries of what's possible. Leading the charge is SpaceX, with its ambitious Starship program, which aims to revolutionize space travel. Elon Musk has been vocal about his vision to make humanity a multi-planetary species, emphasizing the importance of Mars colonization. And SpaceX is developing a fully reusable spacecraft capable of carrying large numbers of people to Mars, making interplanetary travel more feasible. The goal? To launch the first crewed mission to Mars by the 2030s, with plans for a sustainable colony soon after, ensuring a long-term human presence. Starship is designed to be a game-changer, potentially cutting the cost of space travel dramatically and making Mars exploration accessible on a scale never seen before in human history. But it's not just SpaceX. NASA is also heavily involved in Mars exploration through its Artemis program and the ongoing Mars Perseverance rover mission, contributing significantly to our understanding. While Artemis focuses on returning humans to the Moon, it's seen as a stepping stone toward deeper space missions, including Mars, paving the way for future exploration. NASA is working on new propulsion technologies and spacecraft like the Orion capsule to send astronauts to Mars within the next 2 decades, advancing our capabilities. Meanwhile, the Perseverance rover is searching for signs of ancient life on Mars, collecting rock samples, and testing crucial technologies that could support future human missions, laying the groundwork. For example, MOXIE, an instrument on the rover, is already producing oxygen from Mars's carbon dioxide-rich atmosphere, an essential step for future colonies, demonstrating vital technology. International space agencies like ESA, European Space Agency, and Roscosmos, Russia's space agency, are also part of the mission to explore and potentially colonize Mars. Collaborations between nations could accelerate Mars missions, combining resources, knowledge, and technology, fostering a spirit of global cooperation. The timeline is ambitious, While SpaceX is aiming to land the first humans on Mars by the early 2030s, NASA is targeting a crewed mission by the mid-2030s, each with their own milestones. These missions are likely to start with short stays, gradually building toward permanent bases, ensuring a sustainable human presence. The ultimate goal? Creating self-sustaining habitats that allow humans to live and thrive on Mars without relying on constant supplies from Earth, achieving true independence. The race to Mars isn't just about reaching the red planet. It's about establishing a foothold for the future of humanity in space. What was once science fiction is rapidly becoming science fact, and the next few decades will be pivotal in turning Mars from a distant goal into our next home, a new frontier for humanity. Colonizing Mars sounds incredibly exciting, but the red planet presents some enormous challenges. One of the biggest hurdles is Mars's atmosphere, which is vastly different from Earth's. It's incredibly thin, about 100 times thinner than Earth's, and composed mostly of carbon dioxide, making it inhospitable for humans. That means there's almost no oxygen to breathe, and we'll need to bring our own air or generate it on Mars using technology like NASA's MOXIE, which can convert carbon dioxide into oxygen. This is a major focus of current research, as any long-term mission will need a reliable way to produce oxygen for both breathing and fuel. Then, there's the problem of temperature, which is another significant challenge. Mars is a cold, desolate planet, with average temperatures around -80 degrees Fahrenheit, -60 degrees Celsius. That's colder than Antarctica, and it can get even colder near the poles, making survival difficult. To survive, future Martians will need advanced habitats that can protect them from the extreme cold, while maintaining a stable temperature inside. Another significant challenge is radiation, which poses serious health risks. Unlike Earth, Mars lacks a strong magnetic field and thick atmosphere to protect it from harmful space radiation. Astronauts and colonists will face a constant bombardment of cosmic rays, which could lead to serious health risks, including cancer. To address this, scientists are working on creating habitats that can shield colonists from radiation, possibly by building underground or using materials that can absorb or deflect radiation. Water is another critical issue that needs to be solved. While Mars has frozen water in its polar ice caps and possibly beneath the surface, there's no liquid water available for easy use. Colonists will need to extract water from ice or even from the soil, a process that's technically possible but requires energy and specialized equipment. NASA's Perseverance rover is already studying potential water sources, but scaling that up for human use is a complex challenge. Lastly, Mars's low gravity, about 38% of Earth's, presents unknown risks for human health. Prolonged exposure to lower gravity can weaken bones and muscles, affect circulation, and create long-term health problems. Scientists are studying ways to counteract these effects, like using artificial gravity in spacecraft or developing special exercise regimens. These challenges might seem overwhelming, but they're not insurmountable. Space agencies and private companies are developing solutions, from oxygen-generating technologies to radiation-shielding habitats. While living on Mars will require constant innovation and adaptation, the obstacles are being tackled one by one. Humanity's push to Mars will be a test of our ingenuity, but with the right technology, we're closer than ever to overcoming these challenges and building a future on the red planet. Imagine waking up on Mars. What would daily life be like for the first colonists? The reality is both fascinating and incredibly challenging. Colonists would likely live in pressurized habitats designed to maintain Earth-like conditions, oxygen, stable temperatures, and protection from radiation. These habitats would probably be built partially underground or covered with thick layers of Martian soil, which helps shield against cosmic radiation and extreme weather. One of the most important aspects of life on Mars will be self-sufficiency. Colonists can't rely on regular shipments from Earth, so creating a sustainable life support system is key. That means growing food on Mars using hydroponic or aeroponic systems, methods that don't rely on soil but instead use water or mist to provide nutrients to plants. Scientists have already tested growing crops in simulated Martian soil, and while the soil needs to be treated first, it shows promise. Imagine Martian settlers harvesting their own potatoes, similar to what we saw in The Martian, but in real life. Energy production will also be crucial. Mars is far from the sun, so solar energy, while possible, will need to be supplemented with other sources like nuclear power to keep the colony running during long, dusty winters or when sunlight is scarce. Reliable energy will power everything from life support systems to water extraction equipment, making it vital to the survival of a Mars colony. Communication with Earth would also be a challenge, with a time delay of about 20 minutes each way. This means colonists would have to be highly independent, solving problems without immediate help from mission control. Robotics and artificial intelligence could play a big role in assisting with day-to-day tasks and managing crises, such as equipment malfunctions or medical emergencies. Speaking of health, medical care on Mars will be a top priority. Colonists will need to manage their health in a harsh environment, so everything from daily exercise to combat muscle and bone loss in low gravity to advanced medical equipment for surgeries or emergencies will be crucial. With limited medical personnel on Mars, telemedicine, remote guidance from Earth-based doctors, could also become a lifeline. Finally, the psychological and social aspects of living on Mars can't be underestimated. The isolation, the long periods of darkness, and the constant pressure to survive in a hostile environment will take a toll on mental health. Mars colonists will need strong support systems and possibly even virtual reality tools to stay connected with loved ones on Earth and combat loneliness. Life on Mars will be anything but ordinary, but it will also be a monumental step for humanity. The first Martians will experience a completely new way of life, adapting to challenges we can only begin to imagine. Yet, the knowledge that they are the pioneers of a multi-planetary future might just make it all worth it. One of the most ambitious ideas surrounding Mars colonization is terraforming, the process of transforming the planet into an Earth-like environment. But is it even possible, or is it just science fiction? Terraforming Mars would involve making the atmosphere thicker, increasing temperatures, and introducing oxygen so that humans could eventually walk outside without spacesuits. The first step would be to warm Mars up. Currently, the planet is too cold to sustain liquid water, but there are several theories on how to raise the temperature. One idea is to use greenhouse gases to trap heat in the atmosphere, much like how Earth's atmosphere traps heat from the sun. Some scientists suggest that we could release gases like carbon dioxide from Mars's polar ice caps by melting them. This would thicken the atmosphere and create a greenhouse effect that could gradually warm the planet. Another radical idea involves nuclear bombs. Some proponents, including Elon Musk, have suggested detonating nuclear devices over the poles of Mars to rapidly release CO2 and warm the planet. While this is a controversial and extreme idea, it highlights just how challenging it would be to kickstart the terraforming process. Once the planet is warmer and the atmosphere thicker, the next step would be to introduce oxygen. Mars's current atmosphere is mostly carbon dioxide, so we'd need to create oxygen in massive quantities. One way to do this might be through photosynthesis, using plants or specially engineered bacteria to convert CO2 into oxygen over time. Another idea is using MOXIE-like technology, currently tested by NASA's Perseverance rover, but on a much larger scale, to continuously produce oxygen. But even if we solve the temperature and oxygen problems, there's still the issue of Mars's weak magnetic field. Without a strong magnetic field, Mars can't protect itself from solar radiation the way Earth does. Some theories suggest that creating artificial magnetic shields or redirecting asteroids to generate a magnetic field could be future solutions, but these concepts are still in their early stages. So, how long would it take to terraform Mars? The estimates range widely, from a few hundred years to several thousand, depending on the technologies we develop. For now, large-scale terraforming remains more theoretical than practical. However, the science behind it is evolving, and what seems impossible today could be a future reality as we continue to make breakthroughs in technology and space exploration. In the end, terraforming Mars may not be a question of if, but when. While it's a monumental task, achieving even a partially terraformed Mars would be a significant leap for humanity. It would allow us to create a sustainable future on the red planet and could be the first step toward making other planets and moons habitable for life. The dream of transforming Mars from a barren wasteland into a thriving second home for humanity may one day become reality. Colonizing Mars is more than just a technological challenge. It also raises significant ethical and legal questions. As we prepare to settle on another planet, we need to consider the moral implications and the rules that will govern human activity on Mars. One of the first questions is, who owns Mars? According to the Outer Space Treaty of 1967, no nation can claim sovereignty over any celestial body, including Mars. This means Mars, for now, is a global commons, belonging to all humanity. But, as private companies like SpaceX lead the charge to colonize Mars, the lines between exploration and ownership start to blur. What happens when a company invests billions into settling Mars? Do they have the right to control land, resources, or even the future of the colony? How do we ensure that Mars doesn't become a Wild West, with private interests taking over and exploiting the planet? Then there's the issue of environmental ethics. Mars is a pristine planet, and some scientists believe we have a responsibility to protect its untouched state. By introducing human life, we risk contaminating the Martian environment with Earth bacteria, which could interfere with scientific studies or destroy potential signs of ancient life. Do we have the right to terraform Mars, potentially changing it forever, for our own benefit? Should Mars be preserved as a natural scientific laboratory, or is it ethical to transform it into a second home for humanity? Sustainability is another crucial concern. On Earth, we've seen the consequences of environmental degradation, climate change, and resource overuse. Colonizing Mars gives us a second chance, but it also comes with the responsibility of avoiding the mistakes we've made on Earth. Any colony must focus on sustainability, using renewable resources, recycling water and air, and ensuring that future generations can thrive without exhausting Mars's limited resources. The ethical question of human life is equally important. Sending humans to Mars is dangerous, and the colonists will face significant risks, from radiation exposure to the psychological toll of isolation. What ethical obligations do space agencies and private companies have to protect the health and safety of those first settlers? And as we look ahead to long-term colonization, how do we ensure fair treatment and opportunities for everyone on Mars, regardless of nationality or economic status? Lastly, there's the challenge of space governance. Earth is governed by laws and treaties that have developed over centuries, but Mars will be a blank slate. Who will create the laws for Martian colonies? Will it be the responsibility of international organizations like the United Nations, or will private companies have a say? How do we ensure that governance on Mars is democratic, fair, and just, avoiding the pitfalls of colonialism that we've seen throughout Earth's history? These questions might not have easy answers, but they're critical to address as we move closer to colonizing Mars. It's not just about surviving on the red planet. It's about building a future that is ethical, sustainable, and inclusive for all of humanity. The decisions we make now will shape the way humans live and explore beyond Earth for generations to come. While colonizing Mars is an incredible challenge, it's not the final frontier. It's just the beginning. Establishing a human presence on Mars could be the stepping stone for even deeper space exploration, unlocking the doors to other planets, moons, and possibly even other star systems. Mars presents the perfect testing ground for the technologies and strategies we need for long-duration space travel. By developing life support systems, habitats, and energy solutions on Mars, we'll gain critical experience for future missions. These technologies could later be adapted for even more distant locations, like Jupiter's moon Europa or Saturn's moon Titan, which some scientists believe could also harbor the potential for life. One of the most exciting possibilities is using Mars as a launch pad for future missions. Due to its weaker gravity compared to Earth, launching spacecraft from Mars would require much less energy and fuel. This makes it an ideal location to build a spaceport for deep space missions. With Mars as a supply and refueling station, missions to the outer planets, or even the Kuiper Belt, would become more feasible. But it doesn't stop there. Mars could help us prepare for the ultimate goal: interstellar travel. Currently, the idea of reaching planets in other star systems, like Proxima Centauri b, seems impossible due to the immense distances involved. But the technologies and survival techniques we develop on Mars could lay the groundwork for future space explorers to journey beyond our solar system. Imagine a future where humans can live on spacecraft for decades or centuries, using lessons learned from colonizing Mars to ensure survival on long journeys through deep space. Mars colonization could also spark innovations in propulsion technology. The need for faster, more efficient travel between Earth and Mars could lead to breakthroughs in nuclear propulsion, ion drives, or even warp technology, making deep space exploration not just a dream, but a reality. If we can drastically cut down travel time, missions to the moons of Jupiter, Saturn, and beyond become achievable within a human lifetime. As we look toward the future, Mars represents a critical milestone in our journey to becoming a multi-planetary species. But more than that, it's the gateway to the rest of the universe. By mastering life on Mars, we're not just securing the future of humanity, we're paving the way for exploration that could one day take us to the farthest reaches of space. Whether it's new worlds in our own solar system or exoplanets in distant star systems, Mars is the first step in an incredible adventure that could define the next era of human history. In the end, colonizing Mars isn't just about survival on another planet. It's about unlocking the limitless possibilities of space exploration. What we achieve on Mars could change the future of humanity, leading us to discoveries and adventures we can barely imagine today. Mars is just the beginning.